Right. So yesterday we learned the product rule for logarithms, and that was log base b of x times y was log base b of x plus log base b of y. With me? Okay, we developed that one yesterday. Now, let's think mathematical logically. Okay? What's the inverse of multiplication? Division. What's the inverse of addition? Subtraction. So, on this next one, if I switch from multiplication now to division, I should switch from adding the two logs to subtracting them. So this property here is the log base b of x over y is equal to log base b of x minus log base b of y. Okay. Yesterday we described that in words, that we did the product one in words. We said that the product or the log of a product is equal to the sum of the logs of the factors, right? Today it would be the log of a quotient is equal to the difference of its of the logs of the factors. Okay? So in my classes yesterday, we talked about log base 5 of 42 after we did it. And we said that log base 5 of 40, here, let me go back one. We said over here then that log base 5 of 42 could be log base 5 of 6 plus log base 5 of 7, or it could be log base 5 of 2 plus log base 5 of 21, and so on and so forth. It could be log base 5 of 3 plus log base 5 of 14, log base 5 of 1/2 times log base 5 of 84, okay? All those different combinations. As long as these two numbers here multiply to get me this number. Okay? So today, then, these two numbers here have to divide to get this number. So let's go something along the lines of today. Let's say log base 3, okay, of 20. That sounds like a good one. Okay, log base 3 of 20. Okay, so log base 3 of 20 could be log base 3 of 100 minus log base 3 of 5. Right? What she said. Yeah. Because I need to divide this number by something to get 20. Because the subtraction sign is there.
I'm just really confused.
Did you understand how we developed yesterday?
A little bit.
Okay. We used the product rule, and then we switched those into log forms and okay, mixed it around. So the inverse of multiplication is is division. And then, so we have to inverse the other side, too. Okay? Okay? So give me another one. That's equal to log base 3 of 20. Okay, so log base 3 of 60 minus log base 3 of 3. Okay. What about log base 3 of 10 minus log base 3 of 1/2? Does that work? 10 divided by 1/2 is 10 times 2, which is 20. Yeah. Okay? With me? Okay. Our last one is the power rule, and it's actually the easiest one. It's the easiest of all the properties. Okay? What this one is saying is log base b of x to the n power is simply n times log base b of x. We just take the power and make it be the coefficient. Okay. So for instance, here, log base 5 of, I don't want to use x. I'll say 16. Okay. 16 is what in terms of a power? 4 squared, right? Okay. So this, it could be one of those two, right? It's 4 to the second or it's 2 to the fourth. Okay. So what the power property says is that 2 log base 5 of 4 is the same thing. Okay. 4 log base 5 of 2 is the same thing. Now, to show you that I'm not just up here, being all cray-cray, okay, let's go to a calculator. Because we have change of base formula that we can do, right? Okay. Yep, we're going to a calculator. Yep, setting up the main window. So we said it was log, it was log base 5 of 16, right? Okay, 1.72271. Makes sense? What exponent do I have to put on 5 to get me 16? Should be bigger than 1, smaller than 2. Okay, right? And then we said that the other one that it could have been was 2. Come on, 2. There's 2. Times the log base 5 of 4. Or we said it could be 4 log base 5 of 2. Works for any. Now, to sum up yesterday and today, okay, for you on the next 2 pages, there's like green boxes and stuff like that. If you want to fill in the individual green boxes, that's you. Okay? I'm going to put it all onto one page. Okay? So if you just wanted to copy down this one page right over the top of that and say, know this. This is the slide that you've got to know. Okay? So we started with b to the 0 power equals 1. Anything to the 0 power equals 1. And in logarithmic form, we said that that was log base b of 1 equals 0. Okay? That's the first one that you got to know. We call that one the 0 power logarithmic property. Okay? Then we went to the 1 power. B to the first equals b, and we said that that logarithmic property was log base b of b equals 1. When the argument is equal to the base, the value of the log is 1. Then yesterday, we said that the product property was log base b of x times y equals log base b of x plus log base b of y. Today, I gave you quotient. Can't remember. Is there an I in there? Yeah, I-E-N-T. Bad spelling. Don't tell my mom. And we said that that was b to the m over b to the n. We subtract the exponents. So then that makes it b log base b of x divided by y is equal to log base b of x minus log base b of y. Then we gave you the power property, and that was so that was what it was based off of, but really it's log base b of x to the n is equal to n times log base b of x. Okay? Now, where we're going with this, okay? We want to get to next week, we want to solve more complex logarithmic equations. That's our goal. In order to do that, we have to do something that's called expanding and contracting logarithms. Okay? Expanding is just what it sounds like. We're going to make a single log become a bunch of logs. And we're going to write it out. We're going to make it become bigger. We're going to expand it. Contracting is you're going to take this string of logs and you're going to whittle it down into one log. Okay? And we need both of those for next week. Okay? So this is at the bottom of page 831 now. Okay? So the first one is expanding logs. So we take those 5 properties that we just had, and we're going to work them over on log base 4 of 6 times x to the 5th. Now, when you're expanding, the first thing that you do is you apply the product or the quotient properties. Okay. Then you apply your power property. Then, if necessary, you apply your 0 or your 1 property. Okay? You probably won't have to apply the 0 property ever when you're expanding and contracting. Okay? Because very rare do we write plus 0. Okay? But I'll put it on there because it's one of our 5 properties. Okay? So, my question to you is this. What's going on right there? Multiplication, right? Okay. Is that product or quotient? Multiplication. Product, right? Okay. So I've got to apply my product power, or my product property, I should say. So this becomes log base 4 of 6 plus log base 4 of x to the 5th. With me? I took the two things that I'm multiplying in, I gave them each their own log, and I'm adding in between them. Now, my question to you is, what's going on right there? Nope. The argument is 6, right? But is there any way that I can rewrite 6? 2 times 3, right? So there's a product going on in there too. So this would become log base 4 of 2 plus log base 4 of 3. And I keep doing that process until all I have is prime numbers. Okay? It's kind of like when we were doing prime factorizing for simplifying radicals. Okay? You keep going until you get a prime number. So then here, then this becomes plus log base 4 of x to the 5th. Okay? We good with the first red one? Anything that we can do there? No? Okay? I'd be okay with it. Okay? I mean, ideally, I'd like it as 1/2. Because 4 to the 1/2 power is 2. Okay? But I'm sure that we'll both be okay with just leaving it as log base 4 of 2. Okay? We good here on this one? What about this one? We good on that one? What can we apply now? The power property. So this one log base 4 of 2 plus log base 4 of 3 plus what now? I take that power and I do what with it? Put it out in front, right? So I put the 5 out in front and then I write what's left over. Four of x, yeah. Okay? Now, on number, I almost said on number 2, but it's letter B. Letter B, I'm not going to say anything. You walk me through it. So what does that become then? minus what? Log base 7 of x cubed. Okay. Before power, though, no, because this 3 is not in a power. You know what I mean? It's not in the exponent. No, not yet. Here and here need work. Both power properties. So do we get for an answer log base 7 of 3 plus 4 log base 7 of y minus 3 log base 7 of x. Work through me C. Natural log. What you got, Ken? What's going on? Are we multiplying or are we dividing? No. Okay, so we're multiplying, right? Okay, so that's going to be natural log of 3 plus natural log of x plus natural log of y to the third. What? No, we cannot put the 3 in front first because if the exponent of 3 were controlling the whole thing, yes, we could put it in front first. But it's only controlling the y part.
So I meant to put in front the
Natural log of
y.
So just jump right to this one then?
I'll just simplify right away.
Yeah, no, that's fine. That part is okay. Okay, with me? Okay, now let's go in reverse. So if I'm going to go in reverse, what's the first thing that I'm going to apply? Nope. My 0 or my 1s, or if there's a whole number. We'll get to one. I added one, by the way, at the end with that has just a number. Okay. Then what do we apply next? Powers. Then we apply product and quotient. Okay. So here in this one, the first thing that I would apply would be my 0, 1, then power, then product quotient. So here the first thing that I would do is I would adjust that one. Log base 2 of 10 plus log base 2 of x cubed. Right? Take this number out in front, put it in the exponent. Then, this is adding, so that means adding goes with multiplication. So this becomes log base 2 of 10x cubed. And I have it written now as a single log. You want to try them on your own, or do you want to walk through them together? Yeah. Because of the subtraction sign. Yep. Just call it log because it's log base 10.
Yeah.
Okay.
And then it'd be like 12 to the power of 4 and 2 to the power of 4.
Now, could I figure out what 12 to the 4th power divided by 2 to the 4th power is? How would I do that? No. What would I have to use probably? I'd probably use a calculator. Because 12 to the 4th is a really, really, really big number. Okay? And I know this because when I divide it by 16, I get the log of 1,296. Okay? Now, C is a little more complicated. Okay? So, first, I would deal with these two. So that becomes 3 times the natural log of 3 over x plus the natural log of x over 9. Then we got to cube it. So this would become the natural log of 27 over x cubed plus the natural log of x over 9. Then because I'm adding, that makes it a product. Okay? So the natural log here then of 27 over x cubed times x over 9 becomes the natural log of 3 over x squared. See how I got that? 27 divided by 9 is, and x goes into x cubed. Oops, I put cubed twice. Because that's a fraction that can be simplified. Okay? Now I promised you a fun one. Okay, so what would you do first? What would you do first, based off of what we just did today? Be quotient because they're subtracting the two logs, right?
And then we log base of 3 that we said.
So it'd be 2 plus log base 3 of 4 over x. Okay? But now, I can't take the power because it's plus. But is there another way that I could write 2 based off of log base 3? Does that work? What exponent do I have to put on 3 to get 9? 2. So I can rewrite 2 as log base 3 of 9. Now what is it?
So we get log base 3, 36.
We get log base 3 of 36 over x. Because 9 over 1 times 4 over x is 36 over x. Question? Tonight on your homework, you're going to get a sheet. I see it in the back. On the front side, it's going to be expanding, and on the back side, it's going to be contracting. However you want to say it. Okay? What's up?
So you said the front side's gonna be like yesterday, the back side's gonna be like today.
No, both sides are going to be like. So the front side's going to be like this, or the back side's going to be like this, and the front side's going to be like this.